Alright, so now let's talk about tension on an incline plane. So on an incline plane, you're still going to have the same forces acting on the individual parts as you would if they were not on an incline plane. So what I mean by that is that we still need to do the same force diagrams for both of them as we did in the last problem. I'm going to take this one on the incline plane, and I'm going to go ahead and just separate it out on the incline plane. I know it's not as steep, but just pretend. And then look at the forces that are acting on it. I always have my force of weight that's vertically down. And then I have what's perpendicular is my force of weight in the perpendicular to the surface. And then across from that, I have my normal force. My force of weight in the parallel. And my force applied. So force of weight in my parallel. This would be my force of tension because it's being pulled up by the string. And so the only thing I have missing is my force of friction, which will also be working, parallel. And then, this is parallel by the way. And then force of friction. So I'm going to go ahead and do my force formulas for this graph. It looks very scary, but it's not that big of a deal. So I still have my vertical or my perpendicular forces, and I have my parallel forces. So my sum of forces always and forever is equal to my mass times acceleration. So I have my sum of forces in my perpendicular, and that's going to be equal to my force of weight in the perpendicular minus my normal force. Now, in all intents and purposes, this should be equal to each other, so my force on the perpendicular should be equal to 0. Then I need to look at my parallel. Now, this one's going to be a little bit different because this is what we're looking at for the whole system. So my forces of parallel are equal to my force of tension minus my force of friction plus my force of weight in the parallel. Since this is what's going to be the accelerating object, my acceleration is still going to be in this direction just because that's the easiest way for me to determine it. So this is going to be, we'll make this big M this time. Big M times acceleration is equal to force of tension minus my force of friction plus force of weight in the parallel. When I look at my other one, again, I have two forces. I have my force of tension, and I have my force of weight. So this sum of forces formula is going to be easy. It's my force of weight minus my force of tension. Now, the reason that it's the force of weight first instead of the force of tension first is because my force of weight is causing that acceleration. So then I'm going to make this my little m. And so I have little m times acceleration is equal to force of weight minus force of tension. So just like in the last problem, you're going to combine these two to find your acceleration. So I'm going to have my mass times acceleration is equal to my force of tension minus my frictional force plus force of weight in the parallel. So when I combine these, let's pick a different color. So when we combine these, the force of tension is going to cancel out again. And then I'm going to have acceleration multiplied by big M plus little m equals force of weight of little m minus force of friction plus the force of weight parallel. Once you solve your acceleration, you can plug it back into either of the two formulas in order to determine your force of tension.